These are the notes for Module J, Unit 2, Lesson 1. The topic is sound waves and hearing. The essential question is, what is sound? By the end of this lesson, you should be able to describe what sound is, identify its properties, and explain how humans hear it. You'll notice in this lesson that even though we do a brief overview of sound waves, the learning targets are pretty specific, and there are a lot of connections to things that we've already learned in Module J. So we're linking the vocab you've already learned to some specific applications for sound waves. The first learning target is I can explain what sound waves are, that they're longitudinal waves, and how they travel. They're mechanical waves, so they travel through a medium. Then I can explain how pitch, frequency, and wavelength are related. I can explain what makes a sound loud. The greater the amplitude, the louder the sound. And I can explain the 3 parts of the Doppler effect, and we'll get those 3 things in the notes at the end of the lesson. If you look at the lesson preview on page 37, you should notice that you feel pretty good about the things on this preview because we've already covered most of the questions in the lessons leading up to this, and also because you've got some life experience with a lot of these things. So I'm going to jump to the notes. The first question in your notes is, why can't you hear in space? This is a question you should already know the answer to. You've learned that sound waves are mechanical waves, which means they need a medium. Space is vacuum. There's no air in space, so sound waves can't travel. They die in a vacuum. Sound waves are longitudinal waves, and you've learned that longitudinal waves have 2 parts. The compression part of a longitudinal wave is where the particles are packed closer together as the sound wave passes, and then the rarefaction is the part of a longitudinal wave where the particles are more spread out after the wave has passed and before the next wave. Sound waves, because they're mechanical waves, travel through solids, liquids, and gases, and we learned in earlier lessons that waves travel faster through denser materials. So that means that a sound wave will travel fastest through a solid, medium speed through a liquid, and slowest through a gas. And that's because in a solid, the particles are packed closely together, so they quickly bump into each other and pass off the vibrations. Pitch is a measure of how high or low a sound is. And if you're in choir, you play an instrument, you've heard that term before. You know that something with higher pitch sounds higher to our ears, and something with lower pitch sounds lower to our ears. And this is caused by the fact that sounds with a higher pitch have a higher frequency and a shorter wavelength. So those waves are closer together, and that creates something that's a higher pitch. Then a lower sound would have a lower frequency, waves that are more spread out, and a longer wavelength. Loudness is another thing we talk about when we talk about sound. Loudness is measured in decibels. A normal conversation, if you and I were just to talk face-to-face about something, is about 60 decibels. And we know that anything over 90 decibels is harmful to our hearing. So most of us have been at a concert or a sporting event where the sound was so loud that we could actually feel the vibrations of the sound waves in our bodies. And when we leave, our ears are ringing. Those are sounds that are definitely above 90 decibels. They're harmful to your hearing. In fact, you'll find in the notes, or in the workbook, there's a graph that shows typical decibel levels for things in our everyday lives. And a lawnmower is something a lot of us come in contact with that's above 90 decibels. So things like those concerts and lawnmowers, while they're not great for your hearing, if they're every once in a while occurrences in your life, are okay. But if those are things you're doing regularly, for example, if your job is mowing lawns all day, all summer long, you should be using some sort of ear protection because your smallest bones in your body are in your ear. And when they get knocked out of place, when they vibrate a lot from those really loud sounds, that's not something that doctors can repair. Also, if you are a student who likes to listen to music with your earbuds and the people around you can understand the words in the songs that you're listening to, that's too loud. Louder sounds have more energy, and that means that they have a greater amplitude. That's why they sound louder. Those are bigger waves producing bigger vibrations, and because they have more energy, those loud sounds travel a lot farther. That's why you can hear someone shouting at the other end of a hallway, but you can't hear them whispering. The Doppler effect is the last learning target. The Doppler effect explains why a sound might have have a different pitch depending on where we're standing in location to the source of the sound. You have experienced this with the storm sirens that go off in the summer or with a passing fire truck or police car. There are 3 parts to the Doppler effect. The pitch of that sound is higher as the sound approaches us. That's because the waves are coming in closer together. They're higher frequency. So as that storm siren rotates toward you, you hear a higher pitch sound. You hear an accurate or a true pitch when the sound is directly in front of you. And then you hear a lower pitch after the sound passes. So if that siren has passed and is moving away from your ears or your house, then you're going to hear a lower pitch. So the source of the sound is actually emitting the same pitch the entire time, but depending on whether it's moving toward you or away from you, the frequency changes as the waves are closer together or more spread out, and you hear a different pitch. Those are the notes for Module J, Unit 2, Lesson 1. Topic is sound.